Hi everyone, it's time to do the week 9 course notes video. So we're looking at summarizing or displaying data, but starting with summarizing some frequency data. Now let's look first at this frequency histogram. In order to create this, unfortunately it's already been created, but we've got all these scores. Remember we label the scores with X's going from 12 to 24. Rightio. What I would normally have done is said, no, this score goes up to, there's one of them, so we'll put a dot there. None of them, one of them, one of them, three of them, five of them, and so on. I would have put all the dots there. And then you can see that we then draw boxes around them, and that the boxes straddle the central number. Clearly 12 is straddled by the box. And we don't bother leaving gaps between the columns. There's a gap here only because there are no 13s. So there's a frequency histogram. Just while we're at it, look at the frequency polygon, the only difference being that we put all the dots there. And sure, the boxes are where we drew our frequency histogram, but look at what would have happened if I would have drawn my, connected my dots. I would have been drawing a frequency polygon. Now, the only other trick, apart from just joining all the dots, yeah, sure, I can join all the dots, but look down here and look down here. The only other rule of drawing a frequency polygon is, at both ends, at the start and at the beginning, get that dot and connect it down to the next number on the axis at 0. Get the last one, connect it to the previous number on the axis at 0. So frequency polygons should start on the axis, do whatever they've got to do, and then finish on the axis. That is a frequency polygon. The frequency histogram is purely the boxes. So there's frequency histograms and frequency polygons. Why do it? Well, it gives you a visual representation. If there was more data here, I might try and, say, oh look, we've got that sort of trend. I don't know if that came up. I might press pen. You might say, look, we've got some sort of bimodal thing happening. There seem to be two peaks, and I could draw some sort of curve. But at the moment, we just want to look at this around polygon as is. But you can see that, yes, it's a visual representation. I can see where my peaks are, and I can see where the bulk of the data is. So it's just a good visual representation of our data. Now, if we go to the next page, it's saying, well, what about a cumulative frequency histogram? We dealt with the cumulative frequency column last week. It was this fella. Again, press the P, David. It was this fella, cumulative frequency. And that was where we did that zigzag accumulation thing. We said, so far, there's a score of 12, there's only one of them. Then there's no more scores in the next line, so we've still only got one score. Then there's one more score, we've got a total of 2, plus 1 is 3, plus 3 is 6, plus 5 is 11. And that's how last week we created our cumulative frequency column. We also made point that the last cumulative frequency number we had was the same as the total of the cumulative frequency column. If there are 28 scores, this last score must go up to the 28th. And they add up to 28, so that's always going to happen. As for graphing it, well, it's fairly straightforward. I'm just, instead of graphing the F column, I'm graphing the CF column versus a score. So my x-axis is still from 12 up to 24, but I've just done the 1, and then the 1, and then the 2, and the 3, and the 6, and so on. And I can put all my dots there to construct it. And then I create my histogram, which is the boxes or the columns exactly like I did before. So it's still a visual representation, but it's showing the accumulation of where the scores were. Now, what's the difference between that and the next one? There's a bit of a change to what was on the previous page. We're still here doing the cumulative frequency, but for the polygon, we don't join the central dots. I'm not just joining this dot to this dot. Look at what I'm really doing. Look at it down here. I'm joining from the bottom left corner to the top right. Then it went flat because there was no increase. Then bottom left, top right. When I say bottom left, I mean where it already was. So the top right, top right. So look at all that. So yeah, that's how I do these ones. I don't do the dots. It's like, there's an example, join them. Join. Then it went flat. And so on. I know it's not overly neat the way I'm doing it. Freehand's a bit... But here's one I prepared earlier. So that red line is a cumulative frequency polygon, also called an ogive. Okay, a lot of textbooks will just call it an ogive. Use the ogive to find this or whatever. Same thing, cumulative frequency polygon. Again, the polygon is that line, and the cumulative frequency histogram is the boxes. Also note there's no trick at the end of the polygon. I don't have to take it down to the end down here. There's nothing like that for the cumulative. It starts on the axis and it finishes up at the top number. I can see how many bits of data are here. It finished at 28. That's exactly what happened. So there's our cumulative frequency histogram and cumulative frequency polygon that we might need to either construct, which we've just gone through some steps, or we might have to read from. Well, what might we have to read from it? Let's look at this question. Here's the cumulative frequency polygon. Well, it's both here. Here's the histogram, and here this line's the polygon. And if I was asked this question, estimate the median of this data using the cumulative frequency polygon, otherwise AutoGyve, then I would just say, look, there's 28 bits of data. There were 28 students, and I can see that this data caps off at 28. So what I've got to go to is halfway. The median's right in the middle, so I'll go to 14. You can see that's the 14 mark. Go across until you hit your red line. Don't care that the box is there. I'm using the cumulative frequency polygon. I'm not using the boxes, I'm using the polygon, and that was me hitting it, and then I took it down. Now, where is it meeting on the axis? It's exactly halfway between 18 and 19. Hence the median, or the estimate of the median of this data is 18.5. So that's, well, there's many more things you can use it for, but in terms of our course, we may just be asked to estimate the median using that cumulative frequency polygon. So in all those cases, just watch the trap. Don't go to 30 and halve it and then go to 15. 30 might be the highest number on the axis, but the graph doesn't even go there. No, it only goes to 28. So don't let that fool you. Go to 28, halve it, go to 14, right there, across. So the 14th score, the estimate of the 14th score is 18.5. Beautiful. That's what we're using it for. What about group data? Now, look at this data here. We've got a whole stack of data. What is it? A group of 50 Year 10 students were weighed. Yeah, that'll go down well in the schools. And their masses were recorded to the nearest kilogram. Okay, stack of masses here. Now, we want to put this together in a group sort of situation. Now, that's not our task. In this course, we're not giving you blank grids and saying form the groups and all that. If we had tutes, we might play with stuff like that. But anything we're going to do in this course is we're going to give you some boundaries and limits. Say, like, form these groups. And okay, let's look at what's happened here, but just note that we would actually provide this info. What's happened is here, they've suggested to choose class widths of 5 kilos. They've said, look, the data goes from, the lowest is 51, the highest is 79. Make some groups. Instead of just listing 51 all the way through to 79, which would be too many rows, or just involved. Okay, lots of rows. We're just going to make it in groups. And the group they've decided is 50 to 54, 55 to 59, etc. Okay, so, and like it says here, 50 to 54 is inclusive. Okay, we don't double up. We don't say 50 to 55 and then 55 to 59. Then where would 55 go? 50 to 54 is clear. 55 to 59 is clear. So let's look at what we've done on the next page. Here's the classes. And again, for us, we would give you the classes. We might ask you to fill it in, but filling it in would be just going through those numbers that we had in that table and putting them, like doing a tally column. There's one of them, there's one of them, one of them, one of them, one of them, and so on until I found out how many was in each. And this has already been done for us. There are 4 scores in this class, 6 in this class, 12 in this class, and so on. Note that there's also a class center column. That's just to help us with calculations. And just look at it. What's the center of this class? If it goes from 50 to 54, the middle number is 52. The middle number is 57. And then you can see the trend. It's just jumping up by 5s, isn't it? Plus 5, plus 5, plus 5, plus 5. So it's normal for us to say, if I've got lots of data and it's really widely spread, I might do it in classes. My class center is just halfway between the numbers. Average the 2 numbers if you want. The frequency is how many scores landed in there. And then what we would have done previously, like last week, we would have said, what is the score? Let's times it by our frequency and make an FX column. Well, we don't actually have scores here. All I know from this table is that there are 4 scores in the range of 50 to 54. So we get a little bit of an estimate happening here. Say that I didn't have the exact raw data from the previous page and all I was given was this. This is all I had. then the truth is, I know there's 4 scores between 50 and 54, but I don't know what they are. Maybe they're all 50s, maybe they're all 54s. So I've got to do a bit of an estimate. And what we do in this case is we pretend they were all in the middle, okay? In other words, that maybe they weren't, but the average of them was in the middle. Maybe the 4 scores were a 50, a 51, a 53, and a 54. The average of those numbers is still 52. So if I'm going to pick any number as an assumption of what might have been the average in this class, it makes sense that it would be the central number of that class. So all I'm going to do is, instead of f times x, I'm going to do f times cc. So I'm going to assume I've got 4 scores at about 52, that's 208. 6 scores of about 57 is this, 12 scores of 62. So it's still the same as last week, it's just I don't actually have the score, so I have to do an f times class center column. As for the cumulative frequency column, that's as good as normal. Here were my frequencies, which added up to 50, sorry. And here's my cumulative frequency. That 4 scores, there it is. Plus 6 scores is 10, plus 12 scores is 22. There's the zigzag again. I finished on 50, same as what I knew I should have. The total of scores was 50. And the other thing I can see written there is that my sum of my column here is 3245. That is an estimate of the sum of my scores. Again, if I knew the raw data from the previous page, I could just add them all up. But if I only got this table, then all I can do is assume that I have 4 scores, about 52, exactly what I said before. So 3245 would be an estimate of the total of all the scores. So the text goes on to talk about that. So notice that here the mean, or the estimate of the mean I should say, will equal the sum of all the scores, 3245, over the number of all scores, which is 50. So 64.9 is an estimated mean. Okay, not a biggie, but if we gave you that table, we wouldn't ask you for the mean. We couldn't. We'd have to ask you for an estimate of the mean. And 64.9, again, I like to look at if that's reasonable. 64.9, that's reasonable. My data went from something like 50 to 79. 64.9 sounds pretty good to me. Notice if I had done the actual mean with the real data, it was 65.12. But if I wasn't given it, all I can do is estimate the mean. Now, what about the mode? I can't ask the mode here because I don't know what individual scores happen. Again, if I was only given this table, I don't know what each individual score was. So we wouldn't ask you for the mode. We'd ask you, what's the modal class? Which class was most popular? All right, same logic. There are 16 scores. The most in any class was 16 scores, and that most popular class was from 65 to 69. Hence, that is the modal class. Done. So we wouldn't ask for the mode, we'd ask you for the modal class. So we'd ask for an estimate of the mean, we'd ask for the modal class, and as for the median, again, I don't have the individual scores, but I could ask for the median class, which again is just the class that's in the middle. Where's the middle? Well, I've got 50 bits of data. We said last week that to get to the exact center of 50 bits of data, I'd find the 25th and the 26th. The logic is from last week. So what's the 25th score? Where's my ruler? Who used my ruler? Who touched it? Oh, me. Last week I used the ruler and said, look, up to the 22nd score, we've dealt with these 3 classes, but I want to know the 25th and 26th. So up to the 22nd is catered for, and then up to the 38th class is in the class 65 to 69. Hence the 23rd score all the way up to the 38th score lay here, which is exactly the 25th and 26th scores. 25th and 26th scores both lie in the 65 to 69 class. Hence that's my answer. Right there. Both lie in the 65 to 69 class. Great. So it's worthwhile here to do this example. Now, are the numbers shown over the page? It's already done. Okay, but let's just go through what I was saying before. Firstly, here's all this raw data, and the first thing I'll do is check. I don't know. I don't believe everyone. 50 students, is that right? 1, 2, 3, 4, 5. 1, 2, 3. Yeah, it's a 5 by 10 bits of data. There's 50 students. Construct a grouped frequency distribution table for this set of data. Well, last week we just called them frequency distribution tables. It was just the scores and their frequencies. Maybe it had a CF column, maybe it had a FX column as well. We still call it just a frequency history. David, use your words. We still called it a frequency distribution table. This week, we're just doing a grouped frequency distribution table. All right, so let's just go to the next bit. We compiled the data. We did them in these classes, still like we did the last one. We wrote out our class centers. That all looks good. The frequencies we tallied up, and there was 5 of them, blah, blah, blah. Yes, there was 50 scores in total. We said what was the frequency times each class center, assuming that the 5 scores are about 57. So we've done all that. Remember, this just meant sum. The sum of this column is 3715. In other words, the mean, the estimated mean of this data down here is the total of the data, there it is, over the number of data, there it is. So there's the estimate of the mean, 74.3. That looks pretty good to me. And you can see we've also done the frequency histogram polygon and the cumulative frequency histogram polygon. I would have started there. For this side, I would have used the frequency column. I would have put dots at 5, 4, 6, 7, 9, 14, 5. 5 was the height of 57. Now note, there's 2 ways you can label your axes on group data. You can put the 57 in the middle like this, which is great, no problem at all. Or you could label this side to be a 55 and this side to be a 59. And then this side could be a 64. Now, see, it gets a bit messy there because you could say, well, that's 59, that's also 60. So in this, I wouldn't do it. See already, that's 55 to 59, but that's also 60 to 64. In this example, I wouldn't do it. It's much simpler to do exactly what we've done and label it with a 57 and a 62 and a 67 and so on. Put on my dots there. I draw my columns, and then I draw my columns with these fellas, which for my histogram, and then I just join the dots to make the polygon. And remember, I put in this end and this end. To finish off a frequency polygon, you connect back to the axes. On the right hand side, we used the cumulative frequency column. So my answers were a 5 and then a 9 and then a 15 and so on with my dots. I created my columns just like to the left, but I remember that on the cumulative one, I don't just join the dots. I join the bottom left to the top right, to the top right, top right, top right, top right, and I finish up here. Okay. The modal class, the answers here say it's 80 to 84. Why? Because the highest frequency is a 14, and the class that gained the highest frequency was 80 to 84. The last thing it said was the median class would contain the 25th and 26th scores, because again there's 50 scores, so I agree. What's the 25th and what's the 26th? Get my ruler again, and the cumulative frequency says, well, up to the 22nd class, 22nd result. Go on, draw for me. Here's all of these classes. So it's not these, that only goes up to 22nd. But the 23rd through to the 31st scores all lay in the 75 to 79 class. There it is. The 75 to 79 class is the modal class. The median class. David, use your words properly. The median class is in the center of the data. 25th and 26th scores lay in the class 75 to 79. All right. I think that's a pretty succinct chapter, really. Notice in the questions, well, I already started this one just to help, okay, but you can see there's still more to do. I've done the 3 at height 1, the 4 at height 1, the 5 at height 3, but keep on that trend. And then again in the next ones, okay, I started the cumulative one. And then we've done ones where we've given you the data and given you the grid. That's what we'll do in exam, okay? We'll definitely ask you to create the CF column. And then here, well, I should do this one. Just to remind, what am I asked for? Draw and label the cumulative frequency histogram polygon. Okay, let's do one. The cumulative frequency histogram, I'm going to put a line through F. I might have used the F column to zigzag and get the CF, but I don't want to accidentally use the F column because I'm creating my CF. CF. So first I do dots. A score of 1 has a CF of 4. Score of 1, CF of 4. Score of... Why did that go away? Score of 2 had a CF of 13, which would be here. Score of 3 had a CF of 19. Oh, this is hard to see. Score of 4, a CF of 26. Score of 5. Oh, and so on. I shouldn't do the whole thing. But you can see what I'm doing, and then I'll create my columns. Here's my histogram. Etc. So there's my cumulative frequency histogram happening. And for the polygon, remember, I would just join this, and this, and this, and this, etc. And I'd be very clear, if I was asked to do these on the same chart, that I made it clear that this is the cumulative frequency polygon, just showing the marker that I knew which was which, and that this box is the cumulative frequency histogram. Okay, I hope that's useful. It's a very basic intro to this stuff. We don't really get into our teeth that far into it, but if you can cover this stuff, if this stuff has made sense, then great. That's all we need. All right, thank you. Bye.